Hi folks, today I just wanted to make a short video illustrating the UV spectrophotometer we use in the lab called the nanodrop. This is going to be a short video on just the basics. For more on the nanodrop and the UV spectrophotometry in general, check out all the materials on Canvas on this topic. But real quick, the way this works is it's just this little box here. It has this arm. We kind of raise this arm. The reason it's called a nanodrop is because you can pipette really small amount of liquid, like 1 microliter or 2 microliters right there in that little pedestal. And then you close this arm. And this is the fiber optic cable. And so what's gonna happen is light is gonna shoot in here and shoot onto the sample. And the idea behind spectrophotometry real quick, so you can see right there, this little gap where the water liquid will sit. And the concept behind spectrophotometry real quick is that the cloudier your solution is, the more stuff there is in it, right? That's just like really quick basic explanation of spectrophotometry. And so in the case of DNA will absorb light at very specific wavelengths, specifically 260 nanometers. So the cloudier our sample is, the more light it absorbs at 260 nanometers, the more DNA there is in it. And real quick, I just ran a sample. This is what the results look like. And so you have a concentration real quick. The first thing we look at is the concentration of DNA. This says it's 43 nanograms per microliter, which is a good concentration for plant DNA prep that we did a few weeks ago. This is the graph. You want the graph to look something like this, kind of like a little mountain, a little hill. And you can see at 260 nanometers, we get max absorbance. This is absorbance on this side, different wavelengths of light on this side. So 260 nanometers, we get max absorbance. Third thing we want to look at is 260 over 280. So proteins absorb at 280. Now we don't want to purify proteins, we want to purify DNA. So you want this ratio to be between 1.7 and 2, which it is. Over here is 280 nanometers. So you see we have a lot less absorbance at 280 nanometers than we do 260. That's good. That means our sample is primarily DNA. This is a good, well-concentrated, pure DNA sample on the nanodrop. Okay, now I'm gonna try loading a sample one-handed here. So let's see if I can film this and load this sample one-handed. This is another DNA sample we're gonna read. Let me try loading that real quick. Okay, I think I got my little sample on there. I'll lower this arm. Come over here and hit measure. So there goes the arm, kind of coming down, stretching that little water droplet. Fiber optic cable is shooting some light in there. Nanodrop's doing its thing. And now it just reported the concentration and everything over here. Oh wow, very similar, 41.5 nanograms per microliter. That's just coincidence. Very nice looking graph like we saw before. A good 260 over 280 number of 1.83. Remember, we wanted between 1.7 and 2. This tells us that our sample is sufficiently pure or clean from protein contamination. And then once again, good absorbance at 260. So this looks like it's primarily a sample containing DNA with little proteins and good clean curve. Another good sample. Again, please check out the materials on Canvas for a better and more in-depth explanation on what's going on with the nanodrop and how it works. But I just wanted to make this quick video to show you kind of how it works and what it looks like in the lab.